do one more example with you. Got 2 sine squared x plus 3 cosine x minus 3 equals 0. Notice these are not the same trig functions, so I'm going to see if I can find a way to make sine squareds into cosine squareds. And if you look at your Pythagorean identity, there's a way that I can manipulate sine squared plus cosine squared equals 1 to look like this. I could subtract the cosine squared from both sides. So in place of that sine squared, I'm going to put 1 minus cosine squared. So I'll be left with 2 minus 2 cosine squared x plus 3 cosine x minus 3 equals 0. So now I'm going to go through and put my like terms together. Negative 2 cosine squared x plus 3 cosine x minus 1 equals 0. And now I'm ready to factor. In fact, I think I'm going to go ahead and just divide everything by negative 1 to make this first term positive. And then I'm going to factor. So I'll have 2 cosine x and cosine x. And then I believe it needs to be a minus 1 minus 1. Because this would give me negative 2 and negative 1, which makes negative 3. And then negative 1 times negative 1 is positive 1. So that means that 2 cosine x minus 1 equals 0. And cosine x minus 1 equals 0. So 2 cosine x equals 1. Or cosine x equals 1/2, or cosine x equals 1. So if you think about on your unit circle, the place where the first term is 1/2, it's right there at pi over 3. It's also going to happen down here at 5 pi over 3. You can find that by looking at your unit circle. Also, the place where cosine is 1 is right here at 0. That place could also be 2 pi, but a lot of times they'll say make it 0 to 2 pi without including 2 pi. So I would take 0 or 2 pi for an answer there.